In the frozen wilderness of northern Siberia, far from cities and cameras, the ground itself began to explode, not with lava, not with earthquakes, but with sudden violent force, leaving behind massive craters where solid earth had been moments before. This wasn't myth, this wasn't speculation, it was happening, and scientists were racing to understand why. The first major crater was discovered in 2014 on the Yamal Peninsula, a near-perfect hole torn into the permafrost, surrounded by debris flung hundreds of meters outward. There were no signs of impact, no volcanic activity, no prior warning, just an eruption from below. As more craters appeared, a chilling pattern emerged. Many formed in regions where permafrost was rapidly thawing. Beneath that frozen ground lies vast quantities of methane gas, trapped for thousands of years under pressure. As temperatures rose, the permafrost weakened, turning from an unbreakable seal into unstable ground. When methane pressure reached a critical point, the land could no longer hold it. The result was explosive release, a violent rupture that blasted soil, ice, and rock skyward, leaving behind craters tens of meters wide and deep. Some researchers compared the force to a small natural gas explosion. What unsettled scientists was not just the explosions themselves, but what they signaled. Methane is far more potent than carbon dioxide as a greenhouse gas, and once released, it accelerates warming, which causes more thawing, which releases more methane, a feedback loop written into the Earth itself. Field studies confirmed high methane concentrations around several major craters. Satellite data supported the findings. The explosions were real and spreading. Some regions reported loud booms. Others noticed depressions forming before eruption, as if the land were quietly inflating before tearing itself open. The ground erupts, ancient gas escapes, and the planet responds. Are these isolated events or early warnings? Not all scientists agree on how common such crater explosions could become. Some argue they are rare, localized events. Others warn they may increase as Arctic warming accelerates. What is certain is that these eruptions were not predicted, and they occurred far faster than climate models expected. The Siberian methane craters stand as physical scars, places where deep time collided with rapid change. Ancient carbon released in seconds, pressure built over millennia, unleashed in a single moment. In Siberia, the Earth didn't crack slowly, it burst, a reminder that the planet does not always change politely, and that some forces, once released, cannot simply be frozen again. Sometimes the warning is not written in numbers, but blasted into the ground itself.